Because the Jae-won was not available last time, today we will have a two discussion. But Jae-won is a little bit late, so we may start from a lecture by Jun Gi-hong first, and then we'll see whether Jae-won is coming. Then we can have a discussions and then also my lecture. You may see that homework 3 is out already. Okay. Jungi, are you ready?
예, 준비됐습니다.
All right. Then we can start lecture, please. I can see the screen.
Okay, let me start. Hi, I'm Jun Gi-hong. Today's topic is procedures of feed of ocean plant. Here are the contents. Before start, we need to know some abbreviations. FEED is front-end engineering design. E is engineering. P is procurement. And C is construction. I will briefly explain about FEED and EPC from the website below. This figure is about main contracts used in industrial projects. FEED is the process for conceptual development of projects in processing industries. This involves developing sufficient strategic information with which owners can address risks and make decisions to commit resources to maximize the potential for success. EPC is the prominent form of contracting agreement in industrial projects. The engineering and construction contractor will carry out the detailed engineering design of the project, procure all the equipment and materials necessary, and then construct to deliver a functioning facility or asset to their clients. Let's see an example. Here is the life cycle experience of subsea systems. It starts from concept screening, then front-end engineering design follows. Between FEED and detailed design, there is signing of contract. Detailed design is similar with engineering. And next, there are procurement and construction. Here, you need to have project management. This is simply a scheduling. EPC work is ended here. For example, if a small building finished to be built, then the next step is handover. Ocean plants usually follow these stages of life cycle. This is similar process, procedure of equipment supply, design, procurement, manufacturing, shipping, installation, construction and erection, inspection and tests, and handover. And this slide is for front-end loading, FEL. FEL contains FEED part. This figure shows the process of planning phase to FEED. The first phase is for business planning. The objective is defining the business opportunity. There can be technical assessment, milestone schedule, and estimated cost range. The deliverables can be functional requirements and economic evaluation. You should know that this part is done by company. And second page is for basic engineering conceptual. It is called pre-FEED. The objectives are such as confirming feasibility, selecting technology. In this phase, you evaluate alternates, confirm feasibility, and develop process design. Deliverables are rough cost estimates, preliminary schedule, layout, and process design. This part is done by the contractor. And third phase is FEED. In this phase, you refine and modify things done before to be more concrete, like this. This figure is for ship design spiral. Everything does not proceed in a single sequence, but in cycles. Ocean plant design is similar. Let's see the picture. This car is Mustang. It was notorious for ugly hood. The engine size was so big, the engineer found that in later stage that engine cannot be covered by the hood. So there was an unexpected change of shape. There is dependence of cooperation between engine department and engine room arrangement. This is another figure about ship design spiral. I stress the importance of cycles. And this slide is for design pages. The horizontal axis is the stages in FEED and EPC. The vertical axis shows influence and project cost. You can see that influence tends to decrease as procedural progresses. This is because the scope is fixed after the FEED stage due to contract. So the influence is limited. On the other hand, project cost increases as the procedure progresses. Therefore, the FEED stage is very important because it has high influence and low cost. If a problem is revealed in later stage, ugly Ford Mustang can be repeated. Here is key project activities. Key project activities are front-end loading, project execution planning, risk and opportunity management, operational readiness and assurance, and management of change. And this figure shows the differences between good or poor definition and good or poor execution. Comparing A and B, difference is very small, though there is so poor execution. But comparing A and C, difference is very large if there is a poor definition. So good project definition is very important. Let's see the video. Sorry for connecting problem. Okay, then. This figure is similar with previous slides. The front-end engineering design develops the requirements of BFD into design deliverables, leading to a project specification. The transition from select into define at DG3 is a key milestone in the project delivery lifecycle. It is critical that the project retains continuity of key steps, budget, and understanding of any outstanding risks. The feed shall not start until the DE mandates it, usually when the BFD and other key select deliverables have been approved and fully signed off. The BFD should not contain extensive holes in information or outstanding concept selection choices. The feed start is also dependent on completion of any key recommendations from the VAR3 DG3. Okay, thank you for your listening. If you have a question, just feel free to ask me.
Alright, thank you for your nice lecture. So we may move